Hello everyone, welcome to the channel. We have an interesting quadratic equation today. X squared plus I is equal to 0. I is the complex unit and is equal to the square root of -1. We want to solve this quadratic equation in two different ways. First way, let's say our x is equal to some a plus bi, any complex number. Then plug this into our equation. We will have a plus bi all squared plus I is equal to 0. Then expanding this part, we will have a squared plus 2abi and bi all squared. Let's write first. Plus I is equal to 0. And my friends, this part is b squared times I squared, and I squared is equal to -1 by definition. So we have a squared minus 2ab plus 2abi minus b squared plus I is equal to 0. Grouping the real and imaginary parts, we can write a squared minus b squared is the real part, a squared minus b squared plus I times 2ab plus 1. 2ab plus 1 is equal to 0. Now, my friends, if this is equal to 0, the real and imaginary parts are equal to 0. So we have a squared minus b squared is equal to 0, and 2ab plus 1 is also equal to 0. We are to solve this system to reach our a and b. Now from the first one, from a squared minus b squared, let's write here, if a squared minus b squared is equal to 0, then we have a squared is equal to b squared. So whether a is equal to b or a is equal to minus b. So using this in the second one, 2ab plus 1 is equal to 0. Let's check. Now first, if a is equal to b and 2ab plus 1 is equal to 0, then just writing a for b, we will have 2a squared plus 1. 2a squared plus 1 is equal to 0. 2a squared becomes -1. So no solution from this part, since a and b are supposed to be real numbers, for a plus bi being our complex number. The second, a is equal to -b, will give us, in 2ab plus 1 is equal to 0, will give us -2a squared plus 1 is equal to 0. 2a squared becomes 1, a squared becomes 1/2. So a is a is plus minus, say 1/√2, and b is the minus version, actually the inverse version of a. Let's say our solutions become x is equal to a plus bi if a is plus 1/√2, b is -1/√2, or a is -1/√2 and b is positive 1/√2. This is our first method. Let me show you the shorter one. We have x squared plus I is equal to 0 as our original equation. We can write this as x squared is equal to negative I, and just show this negative I as e to the power of I times 3 pi over 2, which is the Euler notation for negative I. Negative I is here on the imaginary axis, and the angle here becomes 3 pi over 2, and the length is 1. So we can say the first root x1 is e to the power of I 3 pi over 4, and the second one is just pi. If you add pi to this, e to the power of I 7 pi over 4. This first one becomes cos 3 pi over 4 plus I times sine 3 pi over 4. And cos 3 pi over 4 is negative 1 over root 2, and the other one is positive 1 over root 2 times I. And similarly, if you write this, you will have positive 1 over root 2 as cosine, negative 1 over root 2 as sine times I. Thank you for watching, and see you in the next videos.